Can you guys see the PowerPoint?
Yes, sir.
Okay, now guys, this is for example, as an instructor, I mean, I always try to cover the material that that students are going to see in 1325, but also I don't make it as hard as for the students taking 1324 that they're going to struggle. So, but every instructor is different. So that's why I chose all these topics. They cover every chapter from that you guys covered during the semester. Okay, I'm going to cover linear equations, quadratic equations, applications of linear and quadratic functions, exponential functions, applications on exponential functions, solving exponential problems, finance applications, solving systems of equations, matrices, sets and Venn diagrams, probabilities, and permutations and combinations. Okay, now some of the slides are slides that I used in the past. Okay, because it covers the topic that I want to get through. So let's begin with the first question here. I think there's like 25 questions that I put down so we can review. Okay, the first one is very important for 1324 and also for 1325 because you're going to be using something similar in 1325. It says find the equation of the line passing through 2 points, which is -2,5 and -4,6. So what do we need? Solution. We need the equation in slope intercept form, which is y equals to mx plus b. So we need the m, which is the slope, and we need the b. Okay. So the slope is m equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the y-intercept is equal to b equals to y minus mx. This is easier to use than the point slope formula. That's why I put this one down to find the y-intercept because it's very, very simple. Okay. I mean, in my opinion, it's easier than the other one. So now, so how do we start? So this is points. If this is point 1, then this is x sub 1, x sub 2, y sub 1, I mean. And if this is point 2, this will be x sub 2, y sub 2. So these are my points. Okay, so if you notice, this is x1, and this is y1. This is x2, and this is y2. So let's plug them in. So y sub 2 minus y sub 1 is 6 minus 5 over -4 minus -2. Now this right here becomes positive, so this becomes 1 over -2. So what's my slope? My slope is -1/2. I found my m, my slope, right? Now I need to find my b. So choose one point, does not matter which one. So in my opinion, guys, I always like to, stay away, or most students like to stay away from negative numbers, right? But in this case, both have a negative number. So it doesn't matter which one you use. So let's use the first point. Okay, so this is a formula to find b. So y minus mx. So my y is 5 and my x is -2. And my slope, we just got it, which was -1/2. So let's plug everything in here. There's my y is 5, right? My m is -1/2. And my x is -2. You can plug this in the calculator just direct, or you can do it by hand. Okay, and this course, 1324, you guys are able to use a calculator, so just plug it in just the way it is, and you get the answer as b equals to 4. And if not, guys, like for example, let's see here. Okay, this is y minus mx. This should have been a negative number here. I forgot to put the negative right here, guys. Okay. Again, I forgot to put the -1/2. So then, guys, so it would have been 4, but I just saw that I forgot to put the m as -1/2. So that's a mistake on my part, but the answer is 4. So then there's my m, there's my b. So there's the equation of the line in slope intercept form. Okay. I repeat, guys, there's a mistake here. It's supposed to be -1/2 instead of 1/2. But the b is equal to 4. Okay. Now, this is also crucial for 1325. Okay. It's called the difference quotient. Okay, now, so solution. First, I need to find f of x plus h. Okay, so that means that I'm going to plug in x plus h for every x. Here it is, plug in x plus h for every x. So f of x plus h, I put like a little star there. That's like step 1. to start out. So I'm going to put here x plus h, which is going to be there, and also here where the x is. Okay, now here what I'm going to do, I'm going to do the x plus h squared and then bring it down over here. Okay, so x plus h squared is the same thing as x plus h times x plus h. So x times x is x squared, x times h is xh, and h times x is hx or xh, which is right there, and h times h is h squared. Now these two, we can combine these two because they're similar or like terms. So this becomes x squared plus 2xh plus h squared. So I'm going to plug that in for the x plus h squared. Now I'm going to bring the other stuff down. So then here I'm going to do the distributive property, right? So negative times x is negative x. Negative, oh, there's like a -1 here, right? But the one's not there. But we know it's negative 1. And negative times a positive will give you a negative, and the 4 we're just breaking down. Now I'm going to do part 2, right? So part 2, I'm going to apply the whole thing on the numerator here. So this is my f of x plus h, right? I just got that. So all this is right here. Minus this is my f of x, which is the original function. Now here I'm going to distribute. So negative, like a -1 times x is negative x squared. Negative times negative will give you a positive, and negative times positive will give you a negative. Hey students, when you have something like this, like a negative over the whole polynomial, there's like an observation here. If there's a negative here, right, it means like a -1 there. So what's easy is all these signs switch them, right? So this positive becomes negative, negative becomes positive, positive becomes negative. That's like an observation that you guys should be aware of. It only if there's nothing here, like an invisible 1. But if there was a 2, then you have to distribute the 2 times every term. Okay? So now, this is key that I always tell my students because, like I said, this is crucial for Calculus 1 and also for 1325. So if the term doesn't have an h, it's got to cancel somewhere. Or I mean, it has to be eliminated. Hint, term without an h will be eliminated. If you don't do that, I mean, if it doesn't happen here, it means some of your algebra is not correct up here. Okay? So for example, we start with x squared. Does it have an h? No. So somewhere there has to be a negative x squared. You see, there it is. Does the 2xh have an h? Yes, so it stays. Does the h squared has an h? Yes, it stays. What I mean by it stays, because there's no other 2x to cancel it or to make it a 0, right? I mean for you to combine like terms. So I tell my students, if it doesn't have an h, it's got to go. For example, here negative x. Does it have an h? This term here? No. So somewhere there has to be a positive x, and there it is. So those cancel. Does it have an h? Yes, it does, so it stays. Does it have an h? No. So there's got to be a -4 somewhere, and there it is. So every term that has an h has to stay. This is the reason why. Because there's an h on the denominator. So that's why you have to cancel that h on the denominator. That's why every term here must have an h. Okay, that's the reason behind it. So here on the step 2, I go a little step further, so I'm going to factor out the h. Right, so if I factor out the h from all these terms, I'll be left with 2x plus h minus 1. And it's always wise to check your work. Do the distributive property to see if we get what's above. H times 2x will give us 2xh. H times h will give us h squared. And h times -1 will give us negative h. So I know I'm on the right track, so I can proceed. Now here comes step 3. So step 3, I'm going to put them all together. The numerator, which is f of x plus h minus f of x, I already have it here, right? I just worked on it on the previous step. So we just bring it down. Now what happens? We have an h on top, h on the bottom, so that becomes like 1, right? So we're left with 2x plus h minus 1 is the correct answer. And again, this is crucial for Calculus 1, which I know most of you guys, that's not your I mean, you're never going to see Calculus 1, but but you will see 1325, and there's a difference of the quotient rule there on 1325. So get used to seeing this if you have to take another math class. Okay. Now, how do we apply this in real life? Like linear functions. Okay, so here it is. It says the manufacturer suggests retail price, which is the MSRP for a base model 2016 Toyota Prius is $25,035. and it is expected to be worth $14,115 in 4 years. So in other words, the price is going to go down. So for A part, it says find a linear depreciation function for this car. And B part, estimate the value of the car in 5 years from now. And C, at what rate is the car depreciating? Hey guys, for C guys, all it is the slope. Okay, so let's start with A. So before we start with A, we have to set it up and get 2 points. Okay, we need to find 2 points. So we always start when the car is brand new, x is 0, right? So when the car is brand new, right, in 2016, x is 0, which is time has, or t is 0, or x is 0, same thing. X and t will be the same, which means, because if you use t on these problems, it has to do with time. But in most cases, we like to use x and y. So when x is 0, the original price is where you started off from. Okay, so when x is 0, y is 25,035. So that's my first point. Now my second point, right, in 4 years means, so in 4 years from here, right, from here when you started, when the car was brand new, it's going to be 4, right? So in 4 years from this point here, it's going to be worth 14,115. So that's my second point. Now this is like the same process that we did earlier, right? We got 2 points. We have to find the linear equation or the linear function for part A. So we do the same thing as before. We have to find the slope and y-intercept. So again, the same process as before. So this is y2, right? This is y2 minus y1. This is x2 minus x1. We simplify it. So we get negative 2,730. So in other words, the slope means that the car is depreciating at this rate every year. Okay. Now I need to find my b, right? So we use the same formula as before. B equals to y minus mx. And my y is, I'm going to use the first one because it's easier. My y is 25,035 and my x is 0. And this is my slope, negative 2730. So plug him in, right? And we get 25,035. Okay, also guys, heads up. When you graph a line, right? Isn't the y-intercept, isn't this my y-intercept? Right, this is only extra information. So this is my b. So without, we could have got the answer without doing all this work here. This is, when x is 0, this is my y-intercept, or the b. But I did the work just in case you decide to use the other point. Okay, but heads up, when x is 0, this is my y-intercept, and b is the y-intercept. You see, that's my slope. There's my b. There's my function. So this is the answer for A then. Okay. Now for B, estimate the value of the car in 5 years. So after you get the function, right, you can estimate it in 5 years, 6 years, 7 years, 8 years, 9 years, whenever you want. So here they wanted to use it in 5 years. So for 5 years, we're going to find f of 5. Right? We need to find f of 5. All we do is plug in 5 on the original. So in 5 years, this is how much the car is going to be worth. You see it's going down. The car will be worth 11,385 in 5 years. So for part C, at what rate is the car depreciating? Remember I told you at the beginning that the rate of change is your slope. So the answer will be, hey guys, this is not negative, guys, okay? Because it's already saying that it's depreciating. Depreciating means that that's going to be, the slope is negative. So a lot of mistakes that students make is that they put negative here, and it's wrong, okay? So the car is depreciating at that rate per year. That's how you apply word problems into a linear function, okay? Now, number 4 is find the vertex, axial symmetry, y-intercept, and x-intercepts of the function. So in this book, they call it the rule x squared plus, or the rule ax squared plus bx plus c. But other authors call it different. So for now, guys, this doesn't have a name. It just says the rule. What's a rule? Okay. So when it's in this form, okay, when it's in this form, this is my vertex in. negative b over 2a, comma, f of negative b over 2a. Hey guys, the second part here, it always kind of freaks students out, like saying, what in the world is this? It's not that bad, guys. So what it means is this is my x value, this is my y value. When you find the x part of the vertex, all we do is plug this number into the original, and you find the y. Okay, so let's see how to do it. So I have to find the vertex, axial symmetry, y-intercept. Hey guys, and here a heads up, the axial symmetry will be the x value on the vertex, and it's a line. So you have to put x equals to whatever negative b over 2a is. And for the y-intercept will always be the c. Why is that? Because to find the y-intercept, you let x equal 0. So that's 0 and that's 0, so the answer will be 0c. That's why that's like an observation there. And if it's in this form, ax squared plus bx plus c, for the x-intercept, we got to factor or use a quadratic formula. Okay, now, so let's find the vertex. We know that a is 1, right? Because we need a and b. We know that a is 1 and b is 10. So negative b over 2a is equal to negative 10, right? Because this is negative, right? Negative, and my b is positive. I should have put a parenthesis here, but that's okay. And my a is 1. So here, guys, my x part of the vertex is negative 5. Now we find the y part, right? So we find f of negative 5, which means I'm going to plug in the 5 there, negative 5 there, and also there where the 10 is. So it's negative 16. So then this is my vertex, negative 5, negative 16. Now, what's the axial symmetry? The axial symmetry, once you find the vertex, guys, you find the axial symmetry. So my axial symmetry will be the x value on the vertex, which is x equals to negative 5. And the y-intercept will just be 0, 9. C equals 9, so it's going to be 0, 9. Okay. Now for the x-intercepts, we got a factor. Hey students, if you guys have a hard time factoring, you're going to struggle in 1325. Why? Because in 1325, you have to know how to factor. You just have to. Okay? So I did a PowerPoint on, I think on week 3 on how to factor. And if you ever need help, you can always come to Sunday numbers, because the first Sunday of every semester, I just do factoring to prepare the students for their upcoming courses, which can be from 0305 all the way to Calculus 1 or even Calculus 2. Okay? So anyway, to factor, guys, the rule is that this sign here makes that these signs are going to be the same, right? The rule is if this is positive, the signs here are going to be the same. And this sign, you always bring it down. So if the signs are the same, they're both going to be positive. Okay? But that's a different story, guys. Like I said, look at the PowerPoint for week 3, and they can show you how to factor. So now you use the zero property theorem, which means that if a times b equals 0, then a must be 0 or b must be 0. So in this case, x plus 9 must be 0 or x plus 1 must be 0. So x equals to negative 9 and x equals to negative 1. So when you plug this in, say that you're doing MyMathLab, it depends what they want it. So be real careful how they're asking for the answer. If it says x equals to a blank here, right? A blank here, it just means they want the intercepts. Like x equals to this would have been negative 9, comma 1. Negative 1. But if they want it in an order pair, then you have to put them in order pair like x and a y value. So it'll be negative 9, 0 and negative 1, 0. Those are my intercepts. Now, I also wanted to graph it, but I should need to improve my technology, guys, so I can graph it on the PowerPoint. I couldn't find a graph that will give you this one here. But this to graph it, guys, is very, very simple. All you do is do your graph and plot in all those points, and just make like a parabola, connect all the points, and that way they'll be the graph. Okay, now again, this is almost the same thing, but the form is different. Now, for number 5, the rule is going to be ax. This is the rule here that what the author states is going to be ax minus x squared plus k. This can be called the vertex form or standard form, and depending on the author or the book that the textbook that the college has for that course. But here, guys, it's called just a rule. Okay, now Hey guys, when it's something like this, guys, this is very, very visual because the vertex is HK. And the axial symmetry will be X equals to H. And the y-intercept, you have to work a little bit, and also with the X, you have to work a little bit. But if it's in this form, the vertex is very visual, and so is the axial symmetry. So these two, just by observing, you should be able to find the vertex and the axial symmetry. Okay, so then, right? Because according to the formula here, guys, right? This has to be negative, right? I mean, for it to be positive. So like I tell my students, always for the X value, whatever is here, just change the sign. That way it won't be confusing. Because really what goes here is minus -3, right? But that's too much at times. It gets confusing to the students. So that's why I just whatever's here on the for the H, always do the opposite, which would be negative. And the K value stays how it is. Okay. So this will be -3, -16. So then, right, that's my H and that's my K. So that's my vertex. So what's my axial symmetry? X equals to -3. Now to solve for y, right? I mean for the y-intercept, we have to let it. These are the rules, right? From basic algebra. To find the y-intercept, we let x equals 0 and solve for y. And to solve for the x-intercepts, we just reverse it. We let y equals 0 and solve for x. So in this case, for the y-intercept, we're going to let x equals to 0. Okay. So hey guys, this is a function, right? But it's the same thing as y equals to x plus 3 squared minus 16. So these are the same. So what's the rule again? We have to let x equals to 0. There it is. So 0 plus 3 is 3, right? 3 squared will give us 9. 9 minus 16 will give us -7. So that's your y-intercept. Okay, now my x-intercept. So okay, yeah, again, guys. So the one like an ordered pair is going to be 0 and -7. So again, there's my function, there's my equation. So we have to let y equal 0. So there has to be a 0 there. Okay. Now we solve for. We add 16 to both sides. We're trying to solve for x. Now here, guys, we're going to square both sides. Square root both sides. So what I did here, guys, I put this term, I put it on this side because I'm used to having the x on the left side. Okay, and I squared it. So don't get confused here. I just put the right side, which is x plus 3 squared, I put it on the left side, and the 16 put it on the right side, and I square both sides. Okay, now every time that you square or that you take the even root of a number, you always put plus or minus. If this is called the index, for which is here. If the index is odd, there's no restriction. It will always be, it'll be positive or negative, but you don't have to put the positive or negative here, only when it's an even root, when you take the even root of something. So the square root means it's an even, right? So that's why you put plus or minus. So we have x plus 3 equals to plus or minus 4. So then we can add a subtract 3 to both sides. So this is what we get. So here, guys, it's going to be -3 plus 4 or -3 minus 4. So we have x equals to 1 and x equals to -7. So those are your x-intercepts. Okay. Okay, now, how do you apply this the vertex into a real life situation? Well, here it is. Number 6, the revenue of McDonald's Corporation, but this is in billions of dollars, for the years 2015. Oh, I forgot to put here 2010, guys. It's another typo here. This should have been 2010 to 2015. My bad, guys. Okay. So r of x equals to -1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So this should have been a 10 here. So it's from 2010 to 2015. Okay. So we have to take that into consideration that the x means the year. So find the vertex. Right. We use the formula from before. So my a is -0.5. I use 0.5 because it's easier to to put it into the calculator, and also, guys, it's easier to do my PowerPoint. Instead of putting -1/2, I'll just put -0.5. And my b is 13. So negative b, it will be negative, right? And this is 13, so it'll be -13 over 2 times -0.5, which will give us +13. because 2 times negative 0.5 will give us negative 1. Negative 13 divided by negative 1 will give us 13. So then to find the y value, right, we find r of 13. So we get 27.5. So that's the answer for the first part, right? 13, my vertex will be 13 and 27.5. So the answer for A will be my vertex. Now the answer for B. In what year during this period was revenue at the maximum? Right, so in what year? So we got 13, so the answer is going to be 2013. Because x equals 10 corresponds to 2010. So x equals 13 corresponds to 2013. So the answer will be, in 2013, the revenue was at a maximum in this year here. Now for C part, what was the maximum range? I mean, maximum revenue to the nearest $1 billion. The y value of the vertex is called the maximum revenue. Okay? So y equals to 27.5, but they want you to round off to the nearest billion. So it's going to be 28 billion. So that's the answer for C, guys. And again, guys, I apologize for the mistake there. It's supposed to be 2010. Okay? I'll fix it. I'll fix it after I'm done here, okay? So let's go to our next one. Solve the exponential equation. So we have 9x equals to 27. Hey guys, here guys, you can do it two ways, by taking the ln of both sides, or by actually using exponent rules. So here guys, I mean, to use the exponent rules, these must be the same base. You see, but they're not. So 9 squared will not give me 81, right? Which is not equal to 87. So then I have to get the same base between 9 and 27, and I believe the common base is going to be 3. Because 9 equals to 3 squared, and 27 equals to 3 cubed. Okay, so there's my 9 will be 3 squared, and my 27 will be 3 cubed. Okay, so now here we apply the power rule. When you have a power to a power, you multiply the powers, right? So 2 times x is 2x. Now here, guys, this is called the same base. This is called the one-to-one property. Okay, it has another name for it, one-to-one property, or the same base, you apply the rule, which is the one-to-one property. If you have the same basis, then the exponents must equal to each other. So that's the value for x. And you can always check your solution. By checking, you're going to plug in 3/2 for the x. There it is. So 9 to the 3/2 is equal to 27. How do we know that, guys? Because again, when I did this section here, like a PowerPoint on this section, this means the denominator is like the index. So this means what's the square root of 9 is 3, and then the numerator is the power. So this is the same thing as the square root of 9 is 3. 3 cubed is 27. Or you can plug it into the calculator, guys, to get the answer. Now here, number 8. It says the assets in billions of dollars for a Prudential Financial Incorporated can be approximated by the function a of x equals to 315, e to the 0.056x, where x equals to 7 corresponds to the year 2007. Find the assets of the following years, 2000 and 2012. So here, guys, all we do is evaluate the function. I'm going to evaluate it at 0 and at 12, because if x equals 7 corresponds to the year 2007, so that means that 0 corresponds to the year 2000. And 12 corresponds to the year 2012. So in other words, for A part, I'm going to evaluate the function at 0, and B part, I'm going to evaluate the function at 12. Okay. So the answer will just be 315 times 1. The answer is 315. For B part, right? This is good to know that 315 is the initial value because time is equal to 0. So it's always wise to know that before the time begins, right? That'll be the initial value. Because remember with the car, with the Toyota Prius, that when it was x equals to 0, remember, and that was the initial value was the price of the car from the beginning. So this is something similar. So evaluate at A of 12. Okay, now here, make sure that that when you plug into the calculator, that's going to be like this, guys, because most students do this. Because when you do the E function or the base E, it gives you a parentheses. And then most people just close it and then they want to multiply it by 12, which is going to be wrong. If you put it this way, it depends on your calculator. This might be wrong because the calculator follows PEMDAS, order of operations. So to make sure it's correct, you always it's going to be e to the power of 0.056 times 12, and then close parentheses. That way, this is the whole exponent. Okay, so make sure it's in that form. So that's your answer, guys, and we round it off to the 10th place. So this will be $616.8 billion. Okay, now this we want to find a function, exponential function. Okay, so this is number 9. A deadly virus has infected the world. I remember, guys, when the COVID-19 just began, I was covering these type of problems or this section at that time. And I remember that I used this example because the virus hadn't spread that much at that time. So I just did it on purpose to see, so students will see the severity of a virus if, as it was heading to. Okay, so for example, a deadly virus has infected the world. At the end of January, there were 2 cases, and by the end of April, the cases had grown up to 128. A part, find a model of the form f of t equals to y naught, b to the t power, where t equals 0 corresponds to the end of the month of January. If the trend continues, how many people will be infected by the end of the year? Okay, so this can actually, guys, you guys can use these type of models, for anything. So this is a good example, guys, because this is something live that happened last year, and it's still happening to a certain point. So what do we do here? Solution, okay? We need to find y naught and b, right? We need to find y naught and b, and then that'll be my function. So now, y naught is the amount present at t equals 0. So the time present when time is 0, right? It was 2 cases, so it's going to be 2. Since t equals 0 corresponds to the end of January, then y naught is equal to 2. Okay, now t1 corresponds to the end of February, and t2 corresponds to the end of March. To the end of February, and then t2 corresponds to the end of March, and t3 corresponds to the end of April. Why do I do it this way, guys? Just so you know that, or you can go straight from here, right? From here to here, guys. But I did it on purpose because a lot of students are more visual. So by doing it this way, students know that in 3 months, right, that 3 months from when it started, even though April is the 4th month, but here, guys, it was saying at the end of January. So by the end of April, it's going to be 3 months. So then you use what we know to find B. So we know that in 3 months, right, there were 128 cases. So this is what we're going to be doing. Okay, and f of 3 means 128, which means in 3 months there was 128 cases, and y naught is equal to 2. So we're going to plug everything in. You see, f of 3 means when t is 3, this is 128. So that's why 128 equals to 2, b to the 3rd power. So we have to solve for b. So the first thing, we're going to divide both sides by 2. They give us 64. Now we're going to raise it to the 1/3 power both sides. Right, that way this will cancel, so or they'll be equal to 1, so b to the 1st power will just be b, and 64 to the 1/3 power is 4, because this means what's the cube root of 64 is 4, and 4 to the 1st power is 4. Or if you want, you can plug this into the calculator. Anyway, b is 4. So I found my y naught and I found my b, so let's plug him in there, right? So this is the answer for A. Okay, now the answer for B then. Right, there's my y naught and there's my b. So for B part, from January to December, right, is 11 months. Because if we count the same way like I did here, it's going to be 11 months. So we have to evaluate f of 11, which means I'm going to plug in 11 for the t for the time. So that's how many cases, guys, there will be. So 8,388,608 people will be infected by the end of the year. And that's like a logical. This can happen. This can actually happen. Okay. Okay. Now let's move on to the next one, to number 10. Number 10 covers the section, I think, chapter 5, which is the financial applications. Here, guys, Gabriel invested his summer earnings of $3,000 in a savings account for college. The account pays 1.5 simple interest. What will be the value of the account after 2 years? How much interest did he earn? So there's my formula for simple interest. Okay. So my PV, right, is a present value is 3,000. My interest rate is 1.5%, right? We have to convert it to a decimal, so it'll be 0.015. And my time is 2 years. Plug everything in, right, into the formula. There's my PV, and there's the interest rate times time. So we get 3,090. So that's how much money will be in 2 years, right? So how much interest did he earn? So we subtract the future value minus the present value to find the interest. So $90. The value of the account after 2 years will be 3,090. Interest earned will be $90. That's how you do number 10. And again, it always says here, guys, there's this key word that says simple interest, means this is a formula they use for simple interest. Number 11 is compound interest, right? This is going to be compound interest. How do I know that, guys? Because check this out, guys. Okay, you deposit $9,000 in an account at your bank that pays 2% interest semi-annually. This right here, guys, means that's going to be compounded, and there's key words for compounded. Okay, and I believe that's on the PowerPoint that I covered in chapter 5. So again, these two formulas are the same, right? Because the I is equal to R over M, and the N is equal to M times T. This is easier to put into the calculator. Okay, so it's always you have to find 7 things, right? The future value, present value, my interest rate, my compounded per year, my time, my I in my hand, right? The I is equal to R divided by M. You see right here, and the N is equal to M times T. So we're looking for the future value, right? How much money will be in the account, right, in 10 years? So that's the future. So my PV is 9,000. My interest rate will be 2.5, right? But we have to put it into a decimal. So it'll be 0.025. And my M is how many times it's compounded per year. So the word semi-annually means 2. My time is 10 years. So for the I will be R divided by M, right? There's my R, and there's my M, which would be 0.0125. And my N is equal to M times T. There's my M, there's my T. For 20. So all we do is plug into the calculator, guys. And very simple, guys. We plug it in just the way it is. So that's my answer. But most of the times, they want you to round off to a nearest penny. So these are my pennies, these are my dimes, right? So if this is the thousands place is here, guys. It's if it's 5 or more, you add 1 to the hundreds place. So it's going to be $11,538.34. Okay. How much interest did you earn? So again, we use a formula, right? The interest earned, which is INT, equals to future value minus present value. So this is my future value, and this is my present value, the 9,000. So that's my answer, guys. So $2,538.34. Number 12, solve by graphing. Hey guys, when you get to 1325, you're going to be solving linear inequalities. Okay. You're going to be solving inequalities, guys, when you get to 1325. But you have to be shading, guys, because with inequalities you have to shade. That's why I decided to put this one in graphing, because you follow the same steps as graphing simple equations. So here, guys, equation 1, y equals to 3x minus 6, right? I need to find my slope and my y-intercept. So here, guys, this is my slope, 3 over 1, and this is my b, which is the y-intercept. So the y-intercept is always the starting point. So I'm going to start at 0, -6, which is right about there. See right there. Now the slope, this is my rise over the run, which means this goes up and down, and the denominator goes across. So since they're both positive, I'm going to go up 3 from the y-intercept, 1, 2, 3, and then 1 across. So that'll be my next point. And then all we do is draw the line. Now to graph the equation number 2, -5x minus 2y equals -10. Most students or other instructors want you to put it in the y equals to mx plus b form. But I like to use it another way, guys. I like to solve it by using the x and y intercept. Okay, but I want to show you that way. I mean that one right now afterwards. So first, let's put it in the form y equals to mx plus b. So I have to solve for y. So my first step, I'm going to add 5x to both sides. So then if 5x is added here, that'll be 0, and then if 5x added to -10 will be 5x minus 10. Now I divide everything by -2. So this is my result. So this is my slope, and this is my y-intercept. This is my starting point. Then I'm going to go down. I'm going to go down 5 and 2 across. 1, 2, 3, 4, 5, and 2 across. So my point will be right there. Okay. Okay, now. So my answer will be 2, 0 because that's where they intersect. Okay, now going back to the way I show my students, because I always have another way to show the students, and they can pick whatever way they want. I draw myself a little table. Okay, so let's pretend that I'm going to draw my table right here on top. I'm going to put x, and I'm going to put y. I'm going to put 0 for x and 0 for y. Why can I do that, guys? Because -10 goes into -5 goes into -10, and -2 goes into -10. So to find the y-intercept, we let x equals to 0. So that means we got -2y equals to -10. Then we divide both sides by -2, so we get y equals to 5. You see, there's my y-intercept. Now to find the x-intercept, we let y equals 0. So if that's 0, right, that's like gone. So we got -5x equals to -10. We divide both sides by -5. So x equals to -10 divided by -5, which will be +2. So it'll be 2, 0. Because this way, this only works if both the coefficient for the x can go into the constant, and also the coefficient for the y can go in there. Because this way you get even integers or integers. Okay. Anyway, guys, that's my result. So the point where they both intersect is a solution, which is 2, 0. Okay, now solve the system by elimination. By elimination, you have to put in ax plus by equals c, both equations. Equation number 2 is okay, but equation number 1 is not. So we need to rewrite equation number 1. Okay, so we're going to add 2y to both sides. So this is my rule now. So this is in the rule that we wanted. We wanted in this rule, ax plus by equals c. So now I got both equations. So here you're going to cancel or eliminate the x's or the y's. It doesn't matter which ones. In my opinion, it'll be easier to cancel the x's or eliminate the x's. Because if we multiply this whole equation 1 by -4, right, it says to eliminate the x's or the y's. So I'm going to multiply this by -4, right, because -4 times x will give us -4x. And if we add to 4x, they'll be eliminated. Okay, but I have to multiply -4 times every term. So -4 times x will be -4x, -4 times 2 will give us -8y, and -4 times 19 will give us -76. You see that'll be 0. So we got -11y equals to -77. We divide both sides by -11. So we get y equals to 7. Now I need to find the x value because it's a point right where they intersect. It has an x value and a y value. I can go back to either 1 or 2. In my opinion, it's easier to go to 1, right? Because the x is already isolated. So let's go to 1. So I'm going to plug in 7 right there where the y is, right here. So -2 times 7 will give us -14 plus 9 plus 19 will give us x equals to 5. So that's my solution, 5, 7. Okay, now, hey guys, I believe I'm going to go over the 4 o'clock, but I think I mean I'm going to continue until I finish, okay? Because this is an exam, a review, and I want to make you guys understand it, okay? So hopefully, I mean I am going to finish it, okay? So here's how you apply that concept into a real life situation. It says here, a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was 1,435, how many adults and how many children were in the audience? Okay, so here's my strategy. I need to find two equations. So I'm going to put seats with seats and money with money. What does that mean? It means that the number, the number of adult seats plus the number of children seats has to equal to 200 seats, right? So if we let x equals to adult seats and y equals to children seats, there has to be 200 total seats, so it's going to be x plus y equals to 200. That's your setup. Okay. Now money with money. If we let x equals to adults, right? The adult tickets are $8, so x will be so here's going to be 8x. And if we let y equals to children seat, the children tickets are $5, so that's going to be 5y. So 8x plus 5y must equal to the 1,435, right? It's going to be money with money. That's my total income. So 8x plus 5y equals to 1,435. Now we have both equations, so now we can actually solve them. Okay, so here we're going to use the elimination method again. So this is equation 1, equation 2. So I'm going to cancel the x's. So multiply by -8. So -8 has to be multiplied times every term, times x, times y, and times 200. So that's my result. And then equation 2, we just bring it over, and this will eliminate. So we're left with -3y equals to -165. We divide both sides by -3, so we get y equals to 55. Now we go back and plug it into either 1 or 2. It's easier to plug it into number 1. So we're going to plug in the 55 for y. Subtract 55 to both sides, so x equals to 145. So then x equals to 145, y is equal to 55. So x represents what? Adult tickets, right? So there's 145 adults and 55 children in the audience. That's how you work these type of problems. Okay, now, hey guys, the Godzilla method is crucial for 1325 for chapter 7 because you have to be doing row operations. So that's why I decided to put it in here. And again, if you're taking 1325, make sure that you know how to use this method. Okay. So now, remember guys from before on the previous workshop, this method, step 1, there has to be a 0 and there has to be a 0. So I'm gonna keep row 1. So that must change, and that must change. These two must be zeros, okay? So I'm gonna use row 1. So -2 times row 1 plus row 2 will give me a 0 here, guys. Okay, but I need to multiply -2 times every term in row 1. And row 1 plus row 3, right? These two I can just add them. And here's my work. Step 1, this is A and B. There's my A part. Right, I'm doing what's here, -2 row 1 plus row 2. That'll be 0, -5, 5, and -10. And like I always said, guys, if you can simplify as we go along, it's going to be less matrices to deal with. This will be the same thing as divide everything by -5, right? So we get 0, 1, -1, and 2. That's going to be row 2. Now here for the B part on step 1, I'm gonna execute row 1 plus row 3. There's my row 1, right, which is right here, the 1, 2, -1, 6, and this is my row 3, -1, -1, 1, and -5. So we add them, right? So we get 0, 1, 0, 1. So that's going to be my new row 3. Now for step 2, right? Step 2, row 2 stays the same, and that has to be a 0, and that has to be a 0. The 2 must be a 0 on the first row, and the first 1 must be a 0 on the third row. So I'm going to change row 1, and I'm going to change row 3. And I'm going to be using row 2. So negative 2 times row 2 plus row 1 will eliminate the 2 on row 1. And here, guys, I need to multiply this one by negative 1, right? Because negative 1 plus 1 will give me a 0, so it'll be negative 1 row 2 plus row 3. And there's my work. Negative 2 row 2, right? We get 0, negative 2, 2, negative 4, plus row 1, right? Which is 1, 2, negative 1, 6. So we execute the operation. So we get 1, 0, 1, 2. That's going to be my new row 1. We do the same thing for row 2 and row 3. Right? We multiply negative 1 times row 2, which that'll be my result. And then we're going to add it to row 3. So we get 0, 0, 1, negative 1. So that's my new row 3. So now, guys, we're almost done. Now I need to eliminate the negative 1, make that a 0, and make the row 1, the 1 on the third column, also be a 0. So for step 3, row 3 stays the same. So row 2 is going to change, and row 1 is going to change. So I'm going to use row 3. So negative 1, row 3 plus row 1, and and row 3 plus row 2. And there's my work. So it's going to give us 1, 0, 0, 3. So that's my new row 1. And row 3 plus row 2 is going to give us 0, 1, 0, 1. That's my new row 2. So then what's my solution? My solution will be 3, 1, negative 1. That's my answer, guys. And this is very crucial to know, like I repeat, for chapter 7. Okay? Now, matrices. It says perform the indicated operation. So I want to find negative 4a, 5b, and negative 4a plus 5b. So this is called a scalar, right? And this is matrix A. So in other words, I'm going to multiply negative 4 times every element in matrix A, which would be negative 2 times negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. But you can skip this step, guys. If you're doing something like this, guys, all you do is negative 4 times negative 2 will give us positive 8. Negative 4 times 0 will give us 0. Negative 4 times 5 will give us what? Negative 20. Negative 4 times 3 will give us negative 12. But I just show you the steps so you guys can see exactly what's taking place. Okay, so the answer for negative 4a is 8, 0, negative 20, negative 12. Now the same process, but now we're going to do 5b. We're going to multiply 5 times every element in matrix B. Okay? So it'll be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. It's going to give us 0, 10, 20, negative 30. Now, for C part, I'm going to do negative 4a plus 5b, right? So I already found negative 4a and I already found 5b, so all we do is going to add them. There's my negative 4a, and there's my 5b. So to add them, all you do is add this is called what's it called? Or the entry A11, and it's called the entry B11 because it means the A11 means the first row, first column. So in other words, I'm going to add the first plus the first, right? And second plus the second on the first row, and then first times plus the first on the second row, and second plus the second on the bottom row. They're going to give us 8, 10, 0, and negative 42. That's my solution. Now for multiplication. Okay, for multiplication, there's certain rules that you have to know. For example, if I want to multiply a times b, right, the inner numbers must be the same. So a times b cannot be done. That's why I decided to multiply b times a, because b times a because B is a 2 by 2 and A is a 2 by 3. Remember that the inner numbers here, guys, must be the same. So that means, yes, I can do it. Yes, it's a match. And the answer will be the outer ones, a 2 by 3. So here's how we do it. So step 1, I'm going to multiply the first row on the first matrix times every column. That's why I put the rows in blue and the columns in red. So I'm going to multiply 1 times 2, 0 times 4. It's going to give us 2 plus 0, so the answer is 2. So 2 goes there. For step 2, right? In step 2, I'm going to multiply now times the second column on the second matrix. That's why I'm going to put them in red. So we do the same process. 1 times 0 plus 0 times negative 2, which will give us 1 plus 0 plus 0 will give us 0. So that means that's 0 on the first row, second column. Step 3, right? So step 3, we repeat the process. So now these are going to be in red. So again, 1 times 5 plus 0 times negative 3 will give us 5 plus 0 will give us 5. So 5 goes right there. How do I know we stop there, guys? Because there's no more columns to multiply by. So now we're going to switch. So step 4, we're done with the first row times every column. Now it's a second row that's going to be in blue. And we repeat the same process as we did in step 1. Now these are going to be in red. And we do the same thing as before. 4 times 2 and negative 2 times 4. So the answer is 0. So for step 5, right, these are going to be in red now, the second column on the second matrix. 4 times 0 and negative 2 times negative 2 will give us 4. So the answer will be 4, so 4 goes there. And finally, these are going to be the next ones that are going to be in red because that's what I'm going to be executing for the second matrix. So it's going to be 4 times 5 plus negative 2 times negative 3. So I'm going to give us 20 plus 6 is going to give us 26. So that's my solution, guys. Okay? There's your solution. Okay, now, these are number 18. I think we need about 7 more to go. And it's already 4:01. See, we can do it like in about 5, no more than 10 minutes, guys. So thank you for your patience. Here, guys, they're going to give you a set. This is called, some sets. This is called the universal set, which means these are the elements that are being considered, which is the element A, B, C, D, E, and 1, 2, 3, 4, 5. And set X has A, B, 1, 2, 3, and set Y has B, D, 1, 3, 5, and set Z has B, 2, 3 as elements. So we're going to find, this means where they intersect, or this means and or intersection. But first of all, guys, let's do this. Because we're dealing with the complement, which is not, right? This means X not or the complement of X, so I'm going to do it here. So if we have A, B, set X has A, B, 1, 2, 3, right? Which means I'm going to go to the universal set, and it's not going to be A, nor B, nor 1, 2, 3, so that's what's left. C, D, E, 4, 5. And again, I did a PowerPoint on this section, guys. So if you're confused on this, go back and watch it. Okay? Now, so for not Y, which means that's Y, the complement of Y means not Y, means you go to the universal set, and whatever Y is not going to be those. So for example, it's going to be B, D, 1, 3, 5. So not B, not D, not 1, 3, 5. So whatever's left. So A, C, E, 2 and 4 are left. So that means a complement of Y or Y not. Same thing with Z. No, so we don't have to find Z, right? I mean, not Z, so I didn't do that one. So guys, here, X intersects Y. What do they have in common, X and Y? They have in common a B. How about a 1? A 1 and a 3. That's the answer for X intersects Y, I mean. How about X union Y? Because remember when I did this section here, this is easier, guys. You're going to put everything in X. You're going to put everything in X, right? Because it's X union Y. So we got X is A, B, 1, 2, 3. Now union Y, if it's already there, I'm not going to put it down again. So Y is D135, right? So the D, right, the D is not here, so that's why I put down D, but the B was, right? The B is here. Since they repeat, I don't put it, I don't put it again. Now let's go to 1. Is a 1 already there? Yes, so we don't put 1. How about 3? Is 3 already there? Yes, so we don't put the 3. How about 5? Is 5 already there? No, so we got to put the 5. That's the answer for X union Y, or X or Y. The U stands for union or for OR. Okay, now X, guys, right? And then here, guys, I put them in order. But you don't have to put them in order if you don't want to, because these are equal sets. So this will be the same thing as this, right? So the answer is correct. Both answers are correct because they're equal sets. Now for C, guys, not C, right? I already did it over here. So that's my answer for C. And for D, intersection between X naught and Y naught. So we go here. That means what do they have in common, right? Or where do they intersect? Do they both have a C? Yes. So it's going to be C. Right? Do they both have a D? No. Do they both have an E? Yes. So he goes in there. Do they both have a 4? Yes. So the 4 goes here. There it is. Do they both have a 5? No. So that's the answer for X naught intersects Y naught. Okay, now X naught intersects Z. So here's my X naught, right? And here's my Z. So let's do this. So we go here on top, right? X naught intersects Z. Do they both have a C? No. Do they both have a D? No. Do they both have an E? No. A 4? No. A 5? No. So they don't have nothing in common, so it's going to be the empty set. You can use that as the answer empty set, or it's going to be like the 0 with a slash over it. These two means the same thing, which is empty set. Okay, now F. This is X union Y intersects Z. But since Y intersects Z is in parentheses, that's what we do first. So I'm going to put X union. So I'm going to go up here, guys, and the the Y intersects Z. So what does Y and Z have in common up here? They have in common a B, right? They have in common a B, a D, not a D. How about a 1? No. A 3 and a 3. How about a 5? No. So that's Y intersects Z. So I'm going to put it up here. Now I'm going to go to X, right? X is A, B, 1, 2, 3. So I put my X, right? Everything for X, I put it down there. A is A, B, 1, 2, 3. Now I'm going to go to the B3. If it's already here, I don't put it again. Is the B already there? Yes. So I don't put it again. Is the 3 already there? Yes. So in other words, that's my answer, guys. So my answer will be the set of elements A, elements B, element 1, 2, and 3. Okay, now, number 19, it says 60 people were contracted and responded to a movie survey. The following information was obtained. So here, guys, they want you to draw like a Venn diagram. Okay. So I'm going to start off. Okay, I'm going to put all this in set notation. Okay. There's supposed to be 60 people. Let's see, right? 60 people right there. That's why U is equal to 60. That's my universal set. Let's see equal comedies, right? Because there's comedies. That's my C. I'm going to let D equal dramas. That's my D. And what else is there? And science fiction. So I'm going to let S equal science fiction, which would be this one over here. That's my S. Now, it says 6 people like comedies, dramas, and science fiction. Why did I put it in red? Because when they give you a Venn diagram of 3 sets, you always start where they all 3 intersect. You see 6 people like comedies, dramas, and science fiction. So this is where I'm going to start right here. You see, that's 6. Now, 13 people like comedies and dramas. So it's going to be C and D. C intersects D is 13. So, right, so we're going to go here, guys, to C intersects D. So it's going to be this section here. So that's 6. This has to be 7, right? Because 6 plus 7 will give us 13. Now let's do 11 people like dramas and science fiction. So dramas and science fiction will be this section here. So that's 6, right? That's what is 10. So this has to be, I'm sorry, this one here. Let me see, dramas. It says here, I don't know, it says here, what was it? Comedies and science fiction. Oh, right here, I skipped it, it was right here. That's why it means this one here. Now, for 11 people like dramas and science fiction, it's the one that I just did right now. It's going to be this part here. Dramas and science fiction is this part here. So that's equal to 11, right? We already got 6, so it's going to be 5 there. Now we're going to see, right? So 20 people like comedies. So all this must equal to 26. We got 4 and 6 is 10, plus 7 is 17. So 17 minus 26 will give us 9. So 9 is in the outside right here, because all this must be equal to 26. Now where are we? Dramas. Dramas are 21. So dramas means all this must be 21. We got 5 and 6 is 11. 11 plus 7 is 18. 21 minus 18 will give us 3. Now we repeat the process for science fiction. So science fiction is 25. So all this must be 25. Everything in the S set. So we got 10 and 5 is 15. So that's going to be 10. Now, remember, guys, there's going to be something out here, right? So we're going to add all these up, right? Something out here, x equals, we're going to add all these up and subtract it from 60, because 60 is supposed to be the total. So we add them all up, so we get 44. So 60 minus 44 is 16. So there's 16 out here, 16 people that didn't like movies at all, or those type of movies. Now let's answer the question. So for part A, this is the answer for part A. There's my Venn diagram. For part B, how many people surveyed like comedies, but neither drama nor science fiction? So how many people like comedies? So we go to the comedies here. How many people like comedies, but not dramas nor science fiction? So the answer will be 9. There's my 9. For part C, how many people surveyed like dramas and science fiction, but not comedies? Okay, let's go to dramas and science fiction. Dramas and science fiction, right? But not comedies. So it's going to be, right? So it's going to be 3 plus 5 plus 10, right? So it's going to be 3 plus 5 plus 10. So the answer is 18. That was the answer for C, was 18. Because in here, how many people surveyed like dramas and science fiction, but not comedy? So dramas and science fiction, right? But not these right here. So that's why you add all these right here. That 10 plus 5 plus 3 is the answer for part C. And for part D, guys, was how many people did not like none of the movies? So the answer is what's in the outside all the sets, which is 16. Okay. Now, lesson number 20. This is a PowerPoint that I did last week. Okay. A single playing card is drawn at a random from an ordinary 52 card deck. Find the probability of drawing a queen, a diamond, a red card, a face card, or an ace. Like I mentioned last week, most people they don't know how. I mean, people that don't play cards, they don't know what they look like. So they're going to be. These are called clovers or clubs. These are called spades. These are called hearts. These are called diamonds. So there's 13 of each. There's 13 clubs. There's 13 spades. There's 13 hearts. There's 13 diamonds. So we have a total of 52 cards. Okay. And we notice half of them are black and half of them are red. Also, face cards. What are face cards? Because the face cards are the one with a face. That's what they call face cards. A jack, right? They have a face. All these are face cards. So every suit has 3 face cards. You see, there's three spades, which are the queen, jack, and king of every suit. So there'll be a total of 12, right? Because 3 times 4 is 12. So there's 12 face cards. So now, so solution, the probability of the number of the event over the sample space. So for all these guys, the sample space is 52 because there's 52 total cards. So now let's do the A part. A queen. How many queens are there? There's 1 on each suit, right? So there's going to be 4. 4 queens over 52, and we just simplify. The answer is 1 over 13. A diamond. So the probability of a diamond, there's 13 diamonds, right? So it'll be 13 over 52. We simplify it, it's going to give us 13 over 52, will give us 1 over 4. A red card, right? Red cards, there's 26 red cards. So 26 over 52 will give us 1/2. Okay. a face card or an ace. There's, for every set, right, there's 3 face cards. So 3 times 4 is 12. And then every suit has 1 ace. So it's going to be a face card ace will give us 12 plus 4, right, over 52. We simplify, will give us 4 over 13. That's really simple problem, guys. 21. Suppose 2 4 dice are rolled. Find each of the given probabilities. The first die shows the 2, or the sum of results is 6 or 7. So this is the formula that we're going to be using. The probability of U and the U of A union B equals to a probability of A plus probability of B minus probability of A intersects B. So then A represents the event where the first die is a 2, right? That's the event for the first die is a 2. And let B be the event, which is a 6 or 7. So this is the first die here, right? Which is 2. The event A is going to be 6. I mean, total 36, but the event A will be 6. Now, event B, that they both, the sum is 6 or 7. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to be 11. So we're going to plug them into the formula. It's going to be 6 over 36, right? Because there's 6 with a 2, plus 11 with a sum of 6 or 7, minus, right, where they intersect. They intersect here and here. So minus 2 over 36. Here's my solution, and we simplify it. So it'll be 5 over 12. Now for part B. Part B, the sum is 11, or the second die is 5. So again, there's 36 is my sample space. So we use the same formula. So let A represent the sum is 11, right? So sum is 11 will be these two here. Sum is 11. So it's going to be 2. For part B, the second die shows a 5. So let B represent the event. The second die is a 5. So second die is a 5 is going to be these here, right? So it's going to be all these right here, right? The second die is a 5. So it's going to be all these right here across. So it's going to be 6. Now, where do they intersect? Will just be right there, guys. That's where they intersect. So it's going to be 1. Plug into the formula. P of A is 2 over 36 plus 6 over 36 minus 1 over 36. The answer is 7 over 36. That's my answer. Okay, now for 22. For how many years the state of California? For many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. Okay. So no, 26 letters on the alphabet and 10 digits make all the numbers. So how many license plates? How many different license plates are possible with this arrangement? So these are my right ones first. These are my letters. Those are my numbers or my digits. There's 26 letters. There's no restriction, right? So 26 times 26, and then all these will be 10s because 10 digits make 10 digits can go here, right? The digits 0 to 9 can go here on every slot there. We multiply them, so that's my result. When the state ran out of new numbers, the order was reversed, right? So reverse means now these are going to be my digits. These are going to be my letters. So again, there's 10 digits, 10, 10, and 10, and 26 for each space there. So we multiply it out, guys. So it's the same thing as A because when you multiply, the commutative property applies. So we got the same answer. Now for part C, several years ago, the number in describing part B were also used up. The state then issued plates with 1 letter followed by 3 digits and 3 letters. There's my letter, followed by 3 digits, followed by 3 letters. So again, there's no restriction, so I would just put 26 times 10 times 10 times 10, and 26 for the rest of the slots. You multiply it out, and that's my result. Now here comes the permutation and combination, guys, okay? Here means the arrangement, schedule. These are 2 words for permutations. Arrangement, schedule, order, or order matters are the key words. And for combinations, these are my keywords. Okay. So a lottery game requires that you pick 6 different numbers from 1 to 99. If you pick all 6 winning numbers, you win for $1 million. How many ways are there to choose 6 numbers if order is not important? That is going to be what 99 combination 6, right? So this you can put in the calculator, guys, and I did show you how to do it last week, okay, by hand. But that's the answer if you put in the calculator. And again, look at the PowerPoint from last week to know exactly how to work it without the calculator. For part B, order matters. So it's going to be a permutation. And same thing, you can plug in the calculator, guys, and that's your result. But again, you can check the video from last week, and you can actually check how to do it by hand. Okay, in exercise 59, if you pick 5 out of 6 numbers correctly, you win $5,000. In how many ways can you pick exactly 5 out of 6 winning numbers without regard to order? So here we go. Okay, so that means combination. But this is a little bit trickier than the one before because it says 5 out of 6 numbers correctly. So 5 out of 6 numbers is going to be 6 combination 5, right? Because you want to get the 5 out of the 6. Remember, lottery need to pick 6 numbers, right? So we need to pick 1 out of 93, right? Because these must be 6, right? Because we're choosing 6 numbers out of 99. So we're going to multiply 93 combination 1. Right, and I put this, what I just explained, this must be equal to 99. That's what we got here. And these must be equal to 6. Okay. We use a calculator, guys, and we get our answer. 6 combination 5 will be 6. 93 combination 1 will give us 93. That's my solution. Okay. Now this is number 25. A financial advisor offered 8 mutual funds in high risk category, 7 in moderate risk category, and 10 in low risk category. An investor decides to invest in 3 high risk, 4 moderate risk, and 3 low risk funds. How many ways can the investor do this? And here, guys, the order does not matter. Okay? You be careful, the order does not matter. So from the 8, right, I want to pick 3. So we're going to do 8 combination 3. From the moderate risk, right, from the 7, I'm going to pick 4. So it's going to be 7 combination 4. From the low risk, from 10, I'm going to pick 3. Right? So it's going to be from invest 3 out from the 10, so it's going to be 10 combination 3. So if we do 8 combination 3, it's going to give us 56. 7 combination 4 will give us 35. And 10 combination 3 will give us 120. We need to multiply them all out, and that's my result, 235,200. So that's how many ways it can be, guys. Hey, guys, thank you, and thank you, and I'm sorry that I took a little bit longer than expected, guys. But I felt that this was crucial to actually go over the PowerPoint complete. Let me stop sharing my screen.
Alrighty. Thank you so much to Mr. Isasi for presenting and kind of going over all the concepts that were covered through this semester. I do want to wish everyone in the audience a good finals week. I hope that you do well and excellent on each of your finals, and I hope that your spring semester went smoothly. I do want to say that I hope your summer semester also goes well in case you do take any summer classes. Thank you again for coming and reviewing for your final, as well as being a wonderful audience. And we hope to see you in the summer in the online tutoring room.